about divisibility rules, which according to what you guys told me in class the other day that you guys have done these before. So we're just going to go through and review each of these rules, and then we're going to I'm just going to give you an example of what that looks like just in case you forget or it's been a little while. We're not going to go through a lot of examples or anything since you've done this before, but we'll just give an example of each one and just go through each of these rules. And then we'll have an activity to practice this in class tomorrow. So the first one, the number 1 we're going to skip over. It's not even going to be consideration because everything is divisible by 1. So we're going to jump right to number 2. Divisible by 2 is if the ones digit is even. And I think most of you will be able to recognize this. So here looking at the ones digit, it's 4. And since 4 is an even number, we know that this whole number is divisible by 2. The next one then will be divisible by 3. And in order for it to be divisible by 3, the sum of all of the digits in the number have to be equal or divisible by 3 themselves. So if we look at this, if we add up these digits, if we have 1 plus 9 plus 6 plus 2, we end up with 18. 18 is divisible by 3, which means that whole number is divisible by 3. So that's how you do 3, and we'll see that same kind of technique here in a few minutes with some other ones. Alright, so let's look at the next two. So we're going to look at 4 and 5. 5 we know is easy, but 4 we'll look at a little more in depth. Ones and tens digits form a number divisible by 4. So for instance, if I had 27,664. We're looking at that ones and tens digit. So this number here, if we pull out that 64, it is divisible by 4 because it ends up giving me 16. And since it's divisible by 4, that entire number is going to be divisible by 4. So it's a little different, but it's a trick and it works. And again, we'll see that again as well with a different number later on. Divisible by 5, the ones digit must be 0 or 5. So that's simple enough. So if I have 106,220, it ends in a 0, so that we know this whole thing is divisible by 5. So that one I think most of you are probably familiar with. So let's go ahead and jump to, we're not going to do number 7. It's a little more in-depth. We might talk about it in class a little bit sometime. But 7 we are going to skip over for now. So we're going to do 6, and then we're going to jump to 8. So 6 is if it's divisible by 2 and 3. So you have to work the divisibility rules for both 2 and 3, because 2 times 3 is 6. So if it's divisible by both of these things, then it's going to be divisible by 6. So for instance, if we had a number like 116,000, let's see. Excuse me. If I had 116,244, looking at this number, divisible by 2, this has to be even. It is, so we know it's divisible by 2. 3, they all have to add up to something divisible by 3. So if I add up all of these digits, we want them to be divisible by 3. So that's 2, and 6 is 8, 10, 18. Again, that's divisible by 3. So we know that this whole number is indeed divisible by 6 because it's divisible by both 2 and by 3. Now divisible by 8, it's a little different, but it's very similar to 4. But this time we look at the ones, tens, and hundreds place. Hundreds digits. Form a number divisible by 8. So the same similar rule as we did for 4, but this time it's the ones, tens, and hundreds. And it has to be divisible by 8. So if we take a look at $1,621,896. So a really big number, but we can look at that and know that it's divisible by 8. Because if I take those last 3 digits, so 896, if I divided those by 8, 8 goes in there once. And now you wouldn't always have to do this division. But we end up seeing that it is divisible by 8 exactly. And again, I apologize for going out of the screen a little bit. However, if you divide that on your paper, you'll see that it divides out evenly with the remainder of 0. And since that happens, we know that the whole number then, 1,621,896, is divisible by 8. Again, I apologize for going out of the screen down there. But if you do that division on your paper, you will see that 896 is divisible by 8. So 2 more. We're looking at 9 and 10, which is just as easy, if not easier, than 5. So we're going to look at 9 and 10. So 9, the sum of all digits, must be divisible by 9. So very similar to 3, except this time is 9. So for instance, we could have 272,000 961. If I add up all of these digits, we have 2 plus 7 plus 2 plus 9 plus 6 plus 1 gives me 9, 10, 11, 20, 6, 27. Since 27 is divisible by 9, that means that this whole number is divisible by 9. And 10, the ones digit, must be 0. So I could have 210,621,980. As long as that number is a 0, the whole thing is divisible by 10. Alright, so what I'm going to do, I'm just going to give you actually 3 numbers, and I want you to list all of the numbers that these numbers are divisible by. So you're going to go through each of these divisibility rules. So we'll call this just example 1, A, B, and C. So the first one we're going to give you is 9,423. So I want you to go through and list, check, is it even, is it divisible by 3, 4, 5, 6, 8, 9, 10. Then the next one we're going to go to is 2,604. And then we're going to go to 12,035. So take a moment, go through each of those numbers, go through those rules, make sure you have all those rules copied down, and then list all the numbers that each of those numbers are divisible by. So that first one is just divisible by 3 and by 9. Because when I add up those digits, I end up with 18, which both 9 and 3 are divisible by. So that means both of those go in there, but it's not even, so that means it's not 2. And if it's not 2, it's not going to be 6. And if it's not 2, it's not going to be 4. If it's not 4, it can't be 8. So that eliminates all of our even numbers. However, the next one is even, so it is divisible by 2. If I add up the pieces here, we end up with 12. So it is divisible by 3. The last two digits, 0 and 4, are divisible by 4, so it's divisible by 4. It's not 5. 2 and 3, so that means it's divisible by 6. 604, so if we look, 8 goes into 60 7 times, so if I just do a quick division here, and 8 goes in there 7 times, so we get 44 left over. Does not evenly go in there. Since it doesn't evenly divide out, it is not 8. And if we add these up, and we got 12, which 9 does not go into 12, so it is not divisible by 9. It doesn't end in a 0, so it is just 2, 3, 4, and 6. And for this very last one, it's not 2 because it's not even. If we add up our digits, we have 1 plus 2 plus 3 plus 5. So we end up with 3, 6, we end up with 11. So it's not 3. 35 is not divisible by 4, so it's not 4. It is 5. It's not 2 and 3, so that means it can't be 6. 8, 0, 3, 5 is not divisible by 8, so it's not 8. 11 is not divisible by 9, and it's not 10. So the only one this is divisible by is 5. So that's the idea here, and that's what we're going to be looking at. Is I'm going to give you some series of numbers, and you're going to go through and determine if they are divisible by each of those. 2, 3, 4, 5, 6, 8, 9, 10. And for now we're skipping 7, but we will get there eventually. It's just a little more complex and a little trickier. So make sure you have all those rules copied down and have those handy somewhere, because you will want those throughout this section.